Okay, thank you all for being here for this talk. Really excited to be at Pygoran. Again, I've been here last year. And now this time we are sponsoring, my company is sponsoring, and really excited about that, about the talk as well. I'll be talking about Django plus ElasticSearch without invalidation logic, which is a common problem that people have. How do you invalidate stuff if you have both Django and Postgres with Elasticsearch? And I'm Flávio Juvenal. I'm a partner and developer at Vinta Software. So I'm Brazilian, based on Brazil. I love coffee, and I brought some Brazilian coffee. So please check our booth, the Vinta booth. And I have 8 years of web development. Here's my contact information. Feel free to reach me anytime. I'm from Vinta, and we came from Brazil for Pygoran. We are one of the sponsors. We are a team of experts from Brazil. We work with companies from the US, helping them evolve their products with top-notch development and UX techniques. We are a team of designers and developers. So for more information, feel free to reach us at the booth or through our website. Okay, so Elasticsearch, in case some of you don't know, it's the most popular search engine in the world, more than Splunk, Solr, and everything, and it's been there for a while now. And it's written in Java. It is a distributed server, scales horizontally with shards, and parallelized queries because it's horizontal. And it has a JSON API, so it's very easy to put data inside of it and make queries using that JSON API. And someone might ask, why do I need a search engine? I can implement this with SQL only, and it will be equivalent of that XKCD. I put those comics there, but I was like, oh, I shouldn't have done that because it's impossible to pronounce XKCD. So, but yeah, it's equivalent of doing that. For reaching the same end result, you are doing a much more complex operation, and that would be implementing a search engine with SQL only. Because search engines have stuff like you can grab data and clean it, like you can get. Oops, sorry, there's an error there. It should be without the accent. Coffee without the accent. You can clean the data removing accents. You can tokenize the data. You can perform steaming, remove suffixes and keeping only the common root of words. You can perform fuzzy similarity, which is quite hard to do with SQL only. And then you can have the words café in French and café in Italian, meaning the same thing if you use some fuzzy similarity techniques. And relevance scoring to ordering the results according to their relevance. It's also quite hard to do that with SQL only. And the process of a search engine usually involves getting a new document, analyzing it, pre-processing it some way, and putting into a database the search engine itself. And for example, Elasticsearch has, on the pre-processing steps, 3 types of pre-processing. The character filters, where you remove characters that you don't want, like HTML tags. Tokenizer, where you grab the phrase and break it at words, tokens. And also token filters, where you, for each word, for each token, you perform some transformation like lowercase, removing accents and stuff like that. And the relevance scoring of search engines usually happens that way. You have a special data structure to performing TF-IDF, which is term frequency, inverse document frequency. So inside the search engine, you have something like that, where you have words as keys, and the values would be the documents and the position where in those documents that word appears. So using this structure, you can implement highlighting. You can implement relevance by doing some calculation like, for each search term, get the frequency of the term in the document. So if the document refers to that term often, probably the document is about that term. But you divide that by the frequency of the term across all documents, because if it's a very common word, probably it's not very relevant. And that's a very basic explanation on how you can perform relevance. And again, SQL won't be enough for that. It will be hard to implement that data structure using simple SQL queries, SQL tables, and everything. OK, but Postgres has full text search capabilities. It can implement TF, IDF, and everything. And again, the relevant XKCD is, as you move forward, your standards for success slip lower and lower. First, you try to dual boot BSD. Then you can want to get back working like you started. And it goes on. Please check the end of that. The built-ins for Elasticsearch are much larger than the ones you find on Postgres. You have many tokenizers, many character filters, analyzers, token filters, analyzers for many languages like Portuguese, and they have an analyzer called Brazilian. Brazilian is not our language, okay, it's Portuguese, but they have an analyzer for Brazilian. And also the query string syntax. Postgres does have a query string syntax, but it's not as great as the Elasticsearch one. You can perform like very simple searches that are very powerful using a special syntax like this one. You want something vegan, and it must be café, similar to café. So that's why you have a tilde after the café word. So you can find that. Café with one F, café with two Fs, coffee as well. And you have the highlighting because of the search engine and everything. And Elasticsearch can do that really well with a very simple query string syntax that you may even expose to your end user. And also faceted search. That's something that definitely Postgres is not great at, because it's a very complex aggregation where you, after the search, you allow the user to filter your search results, but you are also telling the number of the results the user will have once that filter is applied. So this thing specifically is really hard to do with Postgres, because aggregations will be really slow. You have to do many aggregations to implement that. And again, the horizontal scalability, because the data from an index from like a table in the Elasticsearch is spread out across different shards and different nodes. So you can parallelize very well, and you can scale very well. OK, so what's the golden rule? The golden rule, I would say, would be millions of rows or more, or like billions of rows. Probably should use Elasticsearch instead of trying full text search on Postgres. Less than that, or like million, 2 million, 10 million even, you can use just Postgres full text search capabilities and you'll be fine. OK, fine, let's use Elasticsearch. I want to use like Brazilian analyzer. But how to keep data in sync? Because now I have a database, and I have an index I have the search engine with indexes inside, and tables in the database, and indexes on Elasticsearch. How do I keep them in sync? And again, the relevant XKCD, you are working on to fix the problems you created when you try to fix the problems when you create, and then it goes on and on. Because you always get new problems when you try a solution. There are always trade-offs. And yes, there is the invalidation thing, the invalidation problem, when you try Elasticsearch with an existing database. The problem is you can solve that problem with eventual consistency. You can just say, eventually, Postgres and Elasticsearch will be in sync. And that happens because you have data, and you are sending it from your Django application, for example, to Postgres, and you have to send that same data to Elasticsearch. And the queries, again, must happen in both directions as well. And you have to make sure every data you send to one, you send to another. Every data you change on one, you change on another. And the problem with that is that eventually you may get a recently added result that doesn't appear on search, or a recently deleted result that will still appear on a search. So that would be strange, and that's the invalidation problem the title of this talk talks about. And how do people solve that? Haystack is a very common Django library for implementing search engines with Django, for integrating with search engines. And the simplest solution is just update periodically the index, like every 5 minutes. It works, but it's eventual consistency. You can also have a real-time signal processor where you hook into post-save, hook into post-delete, and every time any model is saved on Django and every time you delete something, you update Elasticsearch. The problem with that is that some queries like .update, objects.update, they don't call signal, so it won't get some of the updates. Other libraries suffer from the same issue. It's not a specific Haystack thing. It's just the way it works. You have data in 2 places, and you have to keep them in sync. The solution for that is doing something crazy. Is to integrate Postgres with Elasticsearch at transaction level. The communication happens directly from Postgres to Elasticsearch on both directions. And you only interact, your Django application only interacts with Postgres. It can ignore Elasticsearch. And how's that possible? That's possible through a Postgres extension. It's something that you can install. It's not like a different Postgres installation. No, it's just something that you can download and install in your Postgres instance. It's a Postgres extension. It implements all the behavior through the index access method API, which is something that Postgres has to allow developers to implement their own indexes using other languages, other databases, and all that stuff. There's no need for plugging on the Elasticsearch side. It has MVCC correctness, so the integration happens at transaction level. If you roll back, the changes will be rolled back on Elasticsearch as well. How is that possible if Elasticsearch doesn't have transactions, MVCC transactions? Yeah, it does some tricks, like it keeps dirty rows in Elasticsearch, but filters that out when integrating with Postgres. And it's an integration without passing through the application. It happens out Postgres and Elasticsearch directly. Supports Postgres 10, 11 soon, Elasticsearch, those versions. And we at Vinta, we built a Django-someDB, which is something to integrate Django with SomeDB directly through a new type of index. It has 100% coverage, task coverage, MIT licensed, well documented. If you find some error or something that isn't clear on the documentation, please feel free to create an issue. Supports Python 3.5 to 3.7, Django 2 app, and it's used in production at Vinta. There's a note there. It's used at production, but not to end users. It's used more on the admin side of things. But it should work for end users as well. You may try, but again, it's MIT license, so no guarantees. OK, so to install it, it's on pip. Very easy. To configure, you need to configure your Elasticsearch URL through settings.py. You have to make an empty migration. And on that empty migration, I put the app core there because many Django projects has an app. It's called core or common, usually that. Inside that empty migration, you need to put this, the ZomboDB extension operation. Just that, and that will install ZomboDB for you on your Postgres database. You have to download ZomboDB first and install on your system, and then only do that. And afterwards, you can grab a model, like the restaurant model. It has name and street. And first, you have to define a custom manager. I'm using the from query set here because in case you already have a custom manager, you can use that to couple with compose it with the search query set from Django-someDB. And then you define a ZombodB index with the fields name and street. And what that will do is that will make those fields searchable on Elasticsearch through Postgres, through Django-someDB. And you'll be able to perform the searches on those fields directly through the ORM. So, but before that, by default, if you just do that, by default, the mapping of the of the types from Postgres to the types on Elasticsearch will be like that. There is a default mapping between the types, so you can check that on the documentation. For example, the text will be analyzed by the ZDB standard analyzer, so it's good to check what that will do. But it will work. It will perform like a simple full text search. You can also configure that and get our Brazilian analyzer. You just need to use the field mapping parameter, and you can use any analyzer you want from Elasticsearch. And you can configure that on Elasticsearch and then use it here. Very easy. And now that I've made the index, run it, the migrations for it, and added some data, I can perform searches very easily just by doing .objects, .query string search, and that will perform a query string search on Elasticsearch for the rows of that, for the instances of that model. And here I'm performing a search similar to Brazil with the prefix st. I can also use a ZombodB admin mixing at restaurant admin, and that will add this. You already have the search on Django admin, but now we have the search with Elasticsearch inside Django admin directly. And you can use query string search here as well. That's how we use in production at Finta. And you can also perform regular JSON searches without the functionalities from Elasticsearch. Here, for example, I'm doing a range search, founded at, restaurants founded at 2018, greater than, equal, less than equal, and I'm passing a date, native date type from Python, and that will be automatically converted to the proper type in Elasticsearch. And you can try that to prove that it's really happening, the integration is really happening at the transaction level. You can try this. You make a transaction atomic, you perform a search, you won't find anything, then you create a restaurant named test, then you perform the search again, you get the result, and then you raise an exception. Now that the exception was raised, the transaction atomic will be rollbacked, and then when you check the database again for searching for test restaurant, you won't find it. So it all happens at transaction level real time. Okay, and also you can compose your regular Django-someDB searches with regular Django filters. So it's very easy to integrate Django-someDB with something like Django filter because the search is lazy. It's not happening at real time when you call the query string search method. It's just like a regular filter. It's performed only when the query set is evaluated. So you can compose it. Although that's not the most efficient, the most efficient is to do all the search you can on Elasticsearch. Because what it will do here, it will perform the search first, then it will filter out those results at the Postgres side. If you could filter out on Elasticsearch first, it will be faster. There are some limitations though. Some of them can be fixed with contributors. Relationships are hard, so if you have a restaurant with a foreign key to city, for example, And then you can want to search restaurants by city name as well. If the city name changes, how to touch the restaurant, because it's on different tables. The ZomboDB index is working only on a single table. It's not working across tables. So if you change the restaurant name, you have to somehow touch. If you change the city name, you have to somehow touch the restaurant to update it on Elasticsearch. And you could use a trigger to do that. I guess it's possible to implement that automatically through Django-someDB by automatically adding triggers. Anyway, please feel free to create an issue, discuss that with me, and we may try a solution. Another limitation is that you probably should always use limit, because some of your queries might be too large, like have millions of results, and someone won't really see millions of results if someone is performing a search. So probably you should always use limit, because if the Elasticsearch returns millions of rows, those millions of rows will need to be hydrated on the Postgres side as well, and that will be really slow. The limit can't happen both on Elasticsearch side and on Postgres side. It's difficult because you have two limits. You have the limit inside Elasticsearch and the limit inside Postgres. So you probably should have a hard limit on Elasticsearch queries. And there's no support yet for aggregations, but it's quite easy to implement that. You just need to call the right functions. No support for highlighting, but very easy to implement as well. Contributors are welcome on that as well. And please email Amazon RDS so they can support that. They support other extensions, but they just don't support ZomboDB because I think the ticket hasn't been allocated to anyone. So please send emails to them and ask, please implement please implement ZomboDB on RDS. So right now it only works if you have your own Postgres installation. And you can check our issues as well. There are some of them, not major issues, but some that you might want to check. For more resources, check the links, Elasticsearch documentation, ZomDB documentation, other ways of integrating Django with Elasticsearch, some smart stuff people are doing. Check those 2 talks. Those are great talks. And there is like very futuristic stuff happening called logical decoding replication. It's like a stream of modifications to replicate the same data across different types of databases. Crazy stuff. Check this. And there are also logstash periodic pooling for synchronizing Postgres with Elasticsearch, but that's basically pooling, so not very interesting. So slides are on that page. There are other talks from Vinta at Pygodon. Tomorrow we have a talk from Rebecca about privacy and anonymization. It will be nice. So please check, and thank you very much. Anyone has questions? Do you have time for questions? Anyone questions?
How much access do you get to Elasticsearch directly? Like, could you specify the index you want to search, for example? If you had like multiple indices, splitting like your data split across multiple indices.
I'm not sure if it's possible to specify the index you want, because I'm not sure. Yeah, it's not possible to have 2 indexes for the same table. So you have the restaurants table. It should have only one Elasticsearch index on it. ZomboDB doesn't support 2 different indexes inside the same table. Does that answer your question?
Yeah, thanks.
But about the access to the Elasticsearch features, you have that. You have the dict search. So that's basically all the syntax you can get from Elasticsearch queries. And you can do any type of query there. The only limitations would be because Elasticsearch allows you to batch queries, and that's not possible yet. So you could batch, for example, the facets and the actual query. Right now, that's not possible. With ZomboDB, you have to make another query for the facets. But it shouldn't be slow. It should be just a bit slower. Any other questions? Yeah, if you have any question, please feel free to reach me on Vinta's booth. Thank you very much, folks.